Good day, everyone. Am I audible? Hopefully, I'm audible. Let me know if I'm not audible. Okay, so let's get started. Today we are, yes, today we are talking about NMAP. So I'm sure you may have used NMAP before in the classes, whether it is CH or CSP or CPENT or whatever. So that the problem is due to time constraints and other situations, we might not be able to go through like deeper into NMAP. So that is why I thought maybe we could spend some time with NMAP with the options and the features it offers. So that's what we are planning to do here. Okay. So some of these options you may, come across, you may have used before, and some of them maybe not. So I hope we'll all get something out of it by the time the session ends. Okay. So yeah, with that out of the way, let's start with a simple Nmap, help option, and we'll see what Nmap actually offers. So I type Nmap and I hit enter, and I'll be presented with all these options actually. And these are separated with multiple things like target specification, host discovery, scan techniques, like that we have different sections, and we'll see what kind of things we have in each different sections, and whatever I'm showing you now, the same can also be found at the Nmap man page over here. So when you have free time, if you're interested or if you want to revisit, you can go ahead and explore this. Seems like the link is updated, no problem. Just go to nmap.org, and here you can go to reference guide. There you will have all the options that we are talking today. Okay, so this is a very good resource. I recommend you to explore this when you have some free time, so that you can make use of it and make your Nmap scans even more personalized or tweaked to your requirement. Okay, so let's start with the starting. So that is target specifications. So using Nmap, we can give different types of targets. Actually, we can give domain names, we can give IP addresses, we can give list of IP addresses and all of that. So let's see what do we have here. See, you can pass host names. Host names means uh, just for example, my computer name is Thunderbird, you can give Thunderbird, or your computer name is Kali, you can give Kali. But remember that host name, DNS, resolution should be there, otherwise it would not work. Or in other words, you can give Wipro.com or TCS.com, Apple.in, such kind of domain names, and that is what called host names. You can give it. Nmap will use the backend DNS resolution, and if it can find any IP address for that, it will scan that IP address. Okay. Remember, Nmap can only scan IP addresses. So even if you give IPs or even if you give host names, it has to resolve the backend IPs in order for it to perform the activities. So if it doesn't happen, it will not be able to do that. If your DNS resolution is not good, or if your DNS server is not reachable, you get nothing. Okay, so yeah, like that you can give host names like domain names, and you can give IP addresses, and you can give network ranges also. For example, as you can see, scanme.nmap.org, that's a host name example. Also microsoft.com/24, that is a host name plus network example. And you can also give an individual IP address or range of IP addresses like this. Okay, here you can see we have 10.0.0 to 255, which means it could be 0.1 dot 2 dot 3 dot, and also ending also will be 1 to 254. So ending also can be 1, 2, 3, 4, all of that. So like that you can give hyphens to scan for range of IP addresses like that. So let's see. So nmap hyphen hyphen um, not hyphen hyphen, my bad. Scanme.nmap.org. I'm using the same target for hostname example. So if I initiate a scan, let's see what I'll get. See here we have the host name is resolved first of all, and then for whatever IP address you have for that IP address, we are going to perform port scan. And here I see it is having IPv6 address, yet still Nmap was able to scan. So that should confirm that Nmap scans both IPv4 and IPv6 targets also. Okay, so that is a host. I can also give any kind of network like my network right now is 10.0.0./24. So whatever devices are there in that network, they all will be scanned. But because I gave like the entire network, it will take more time than a typical single network. Okay. Now you can see one is scanned, 100 is scanned, 160 is scanned, 161, 189. You get the idea. Okay. You can give a range of IP addresses or a network IP addresses like that. Or you can also give single IP address like 159 or 189. You can give individual IP address also like that. Okay. So that's what we have. The first one, that is basic network ranges. Apart from that, you can also give IL, and you can provide a file name, or you can give IR and decide how many number of devices you are going to scan. Okay. So IL is where, sometimes you can perform network scanning using other tools, like net discover maybe, or your own ping sweeping maybe, if you write your own script or something. So we have a lot of networking tools available, and you can perform network scanning with any of them, or you might even be writing IP addresses in a list by yourself. Open notepad, write all of your target IP address in a list, and then you can give that list of IPs to Nmap to scan, saving you time. For example, here my target will be 236 and 189, 236, 189, 160, and 101. So what I can do is I can create a notepad, nano ips.txt, then I can write my IP addresses. What is the last one? 1, 160, 189, 236, 236. Like that, you can give list of IPs, and then you can use that IP address list by giving -IL and the file name, which is ips.txt. Okay, like that you may have 5 IPs, you may have 10 IPs, you may have 200 IPs, all of them either using automated tool or by using your own manual method. You can add all the IPs into your file, and you can scan those files using -IL. Okay, so if I hit enter, that's going to scan those IPs which are in the file, and you'll only get report of that specific IPs. Okay. Then we have IR. So like I told you, you can randomize IP addresses. Generally, when you give any IP address range, Nmap will actually go through it in a sequential order. Instead, you can go for random order actually. This can be particularly helpful when you're scanning large networks, because when you're scanning large networks, IPs may not be immediately available in a sequential order, so scanning randomly might give you a much faster response compared to going through it sequentially. So in that case, we can go ahead and give minus IR in order to scan for random IP addresses. Okay. For example, let me show you. Um, right now, I don't have any specific target in mind, but if I give NMAP minus IR, then I can give how random do you want, like that, some sequence actually. So for example, if I give 100, it's going to generate random 100 IP addresses of public IPs and it will scan for them. If I give 1000, it will generate 1000 random IP addresses and it will, search for them. So if you don't have any kind of limit, you can simply give zero. Zero means unlimited. For now, I'm just going to go with 100. Let's see what it will do with 100. When I'm doing the scan, if I scan with every port number, that could take a lot of time. So to save my time, I'll just pick one port number. Um, which port number should I pick? Let's go with default 80 port number, and then I can launch this particular thing. So hit enter. Now this is going to generate 100 random internet IP addresses and it will scan for that specific 100 IP addresses, and if they have 80 port number, it will show us. So let's see how long it's going to take. Okay, so that is done. How much long it took? It took 16 seconds. And you can see we have random IP addresses all over the place. We have 87, 13, 22, 122, where 80 is filtered. We have 91 filtered. This is, what is this? No cable virginum, something. I don't know, whatever domain that is. Again, filtered. We got 163 filtered. We got one more, Sinky, whatever that is, rr.com filtered. So I have a lot of filtered. Let me ask for only open one. So we did not talk about that yet, but in NMAP we have output manipulation. Where is it? Yeah, here under output manipulation. See, we have hyphen hyphen open. So if I do that, it will only show you open port numbers, not filtered ones. So hyphen hyphen open. I'll also increase my randomness to 1000. Let's generate 1000 random IP addresses and see how many of them have the 80 port number open. So 100 took 16 seconds. So if I double it or multiple that with 10 more, probably 10 into 100 plus 60, 160 seconds. So within 160 seconds, I'm expecting a result. Let's see. So yeah, that's what IR randomized IP addresses and the scan on the internet. This is very much helpful if you're a real bad guy. You don't have any specific pen testing goal or target. You're looking for some vulnerable weak port number that you want to hack on the internet. So in that cases, this is very helpful because I don't see how this can be helpful for a pen testing activity when the IPs are randomized. Okay, so that is IR. Then what else do we have under target specifications? We have exclude, which means out of all the IPs that you have picking up, if you don't want to pick any specific IP or any bunch of IPs, you can provide that. Or if the IP addresses are too many, again, save them into a file and say hyphen hyphen exclude file, and whatever IPs are mentioned in that specific file will be not scanned. This is particularly helpful. I don't think we have talked about that in any class. This is helpful because when you're doing pen testing or when you're doing, for example, we have a lot of CPENT students in the Discord, right? So when you're going for CPENT examination or labs, they will clearly tell you what is your scope and what IPs we should not, scan or perform attacks on. Okay, but still you may forget things and you may start scanning them also. So to avoid that, what you can do, if it is one IP, two IP, you can just give hyphen hyphen exclude, and that IP will not be scanned. Whereas if you have a bunch of IPs that you do not want to be scanned, then you can save them into a file and give exclude file as a file input. Okay, for example, let's say Okay, scan is done meanwhile, and I can see this is interesting. Google user content. Let me try to access this. Copy. On 80 port number, it is open. So let's see. What do we have? Connection was reset. So domain is good. 80 is good, but it is not allowing me to access. Similarly, we have a secure server over here. Let's try that also. Copy. Okay. Precious, precious hospice. Okay. So this is what they have. Host.s, secure server something. Yeah, like that. What is this? Walter user content. Whatever, you get the idea. So we are able to get all the 80 port numbers using I asked. Now, as I was saying, if I don't want specific kind of content, then what can I do? Okay, like I said earlier, I was scanning, let's say 10.0.0.0/24, right? Out of all of this, I don't want to scan my router. I don't want to scan my router. So what I can do is I can say hyphen hyphen exclude and 10.0.0.1. Okay, so this way it will scan the entire network excluding that one specific IP address. Okay, so if I hit enter, let's see the output now. Okay, scan is done. Scroll up and see 10.0.0.1 is no longer scanned, 10.0.0.2 is scanned, but not the one. Like that, I can give multiple IPs using commas or create a file, add all the IPs into the file and use hyphen hyphen exclude to get the similar output, but for huge number of IPs. Okay. Now, apart from that, yeah, with that target specification section is done. So let's see what else do we have. So next what we have is host discovery. All the type of scans that you can use to perform only identifying IPs, not the ports, not the services, only the IPs. Okay. So first we have is list scan. What it will do, it will simply list the targets to scan. For example, if I am about to scan like these, how many IPs will I be scanning? Okay, that if I want to know, I can give minus L, what is that, capital L, small l, smallest capital L. Okay, so if I hit enter, that should, show me all the IPs that I'm about to scan. So just to see what kind of IPs can be list, part of the scan, if you want to identify, that's what you will get with minus small s capital L. Okay. Then you have the very popular -sn, in which we are going to perform ping scan. Specifically, when you execute this command, generally it will do a bunch of things. And out of them, if you add -sn, it is going to disable the port scanning, which will be left with only the ping activity that you do to the target. So if you give that, it will skip the port scanning, and then whatever IPs are responding, those IPs will be listed out to you like this. Okay. And NMAP has various different types of ping based communications, actually ICMP ping, TCP ping, UDP ping, like that. So we can see them all as we go down. Okay, so the opposite of this ping scan is minus capital P small n. So in the previous one, it will disable the port scan and will only perform ping activity, and in the capital P small n, it will disable the ping scan and proceed to directly the port scan. Okay, so if we execute that, minus capital P small n, that is going to skip all the ping scannings and directly go to port scanning. With this, since we don't know what IPs are already turned on, Nmap process to scan all the devices, and some of them will respond, some of them will not, as usual. Okay, what you have to remember while doing this scan is This ping scan might or might not work in all the cases, because sometimes we will have devices with ping enabled, but there are some situations where ping will be disabled purposefully in the firewall. In such cases, uh, minus capital P small n will not result any kind of positive responses. Okay, so here you can see it scanned again all the devices, same, but network scan did not happen. It just went with all the IPs that it could find and gave you all the results. Okay, so then you have different types of network scans that you can do. Like as you can see, minus PS is going to perform TCP SYNAC based scan, and we have minus PA and PU and PY, where it will perform UDP scan for PU and PY for SCTP discovery scan, whatever ports you have. So like that, if you want to perform specific kind of thing scans like that, you can proceed to do that too. The reason why we have them is sometimes devices with ping disabled, but they can still communicate with uh, TCP communications, UDP communications like that. So in that cases, this one will be very much helpful. So keep that in the back of your mind. So in case of when you have a target with no ping, you can make use of these scans. For example, let me take the ping scan, specifically TCP SYN scan. So NMAP, if I give PS for TCP SYN scan, and if I give 10.0.0.160, that's going to perform ping based scanning to the target, and then it will try to perform regular communication to identify the port details. Okay. So then we have again specifically ICMP echo based scanning, timestamps based scanning, and also net mask request discovery. So again, if you want to specifically perform ICMP echo specifically, then you can go for minus PE. Same logic, if the ping is disabled on the target, it will not give you any kind of response. Similarly, you can extract the timestamps of any specific service or devices using timestamp scan, and same process with minus PM, whereas we can perform net mask request discovery probes, which means whatever request the target is sending, that request you will try to identify, and through that you will try to identify devices. Okay. Similarly, if you don't want to go with TCP UDP, you can go with typical IP protocol also with minus capital PO. You will not see any noticeable difference here. That is why I am not doing them all, because like I said, you will not see any observable difference between the scans unless the target has a specific limitations to those specific ports. Okay. So, but having an option is always a good thing, because in the event of when your target doesn't have ICMP ping or ARP ping or TCP SIM packets, in that cases you can go with alternatives and get the results. Okay. Next, what we have is minus N or capital R. This is one of the most overlooked scan actually. Let me tell you. So first of all, we have minus small n. Minus small n means do not do DNS resolution, because every time you perform an IP address scan, especially remote level, if you remember earlier, every time you did the scan, it will also do this DNS resolution, getting the backend uh, host name. Where is it? Did I did? Yeah, see here, extracting the backend host name. This sometimes it can be helpful, sometimes it may not be helpful. But every time you enable DNS host name resolution, that could take more time, especially when you're scanning large ranges. Okay. In that cases, adding minus n will save that 1 millisecond. It may not be that crazy for you now, but when you're scanning like thousands of IP addresses, those milliseconds will add up and will give you faster results. So that is why minus n is useful. Okay. Similarly, minus r here is the opposite of minus n, where it will ask for DNS resolution even in the local and remote level. If you want the DNS resolution to happen for some reason, and you want the host names to be extracted, minus R is your choice. Okay, let's try both of them here. So if I say nmap and minus n and then minus IR 1000, earlier it did not give me host names for some of them, but now I'm going to ask for all of them, minus P80. So now it will not do DNS resolutions on all the IPs that we are extracting. Okay, earlier when I do the same scan, we got like a bunch of things. Let me also add minus minus open. This time it will ignore all the DNS resolutions, giving you faster results. Scan is going on. Scan is still going on. 22% done. In this situation also, if you remember minus IR and minus SL, if I combine both of them, it will first identify what IP address it's going to generate and show me, and then I can proceed to scanning. So like that also we can do just to see the IPs before you actually ping. We have seen that before. Only 22%, 22% done. 72% done, that's great. Now, this is all without doing any DNS resolution. Imagine how long it's going to take if I ask for all the IPs to perform DNS, resolution. So that will take even longer time. Okay, how much is done? 97. That's good. Almost there. Okay, it's done. So now I ask for DNS resolution on all the devices. Sorry, no DNS resolution on all devices, and you can see no extra host names, extra DNS names are shown to you. So that is with minus small n. Now what if I give minus a capital R, which is give me DNS resolutions all the time? Again, it will try, but depends. If it has, it will extract, otherwise it will not. Same thing. So if I hit that, let's see. This is going to take a while compared to the last one. So let's see what other options we have in this. So apart from that, we have hyphen DNS servers, especially if you want to use a custom DNS server. For example, let's say um, I'm in right now India, right? So if I try to perform scan on any Chinese IP address ranges, my ISP in India might not allow that. Okay. Similarly, if I'm in China and then if I try to access some of the other services like Google service or something, my Chinese ISPs might not allow me to access them. So in that cases, if I want to use another DNS server which is either faster or having more resolution or for whatever other reason for security, if I want to use such kind of DNS servers apart from what I get with my ISP, in that case, I can go with hyphen DNS servers, and that's how I can communicate. Let's say I don't want my DNS communications to be going through insecure mechanisms. Then I can go for maybe Cloudflare or maybe Google's encrypted DNS server and mention that encrypted DNS server here. So my DNS queries will happen through that custom DNS server that I specify. Or I can go with a system DNS. So whatever DNS that is configured in my operating system, Let's say my network may have a different DNS server, but in my computer I can set up a separate DNS server. And if I use hyphen hyphen system DNS, it will go with that and it will use whatever is there in the system DNS. Okay. So next we'll see that. See, earlier we did not have this. If you remember, earlier when I'm hitting enter, it simply says ping scan, ping scan, ping scan. But now see, before it does any kind of scan, first it does parallel DNS resolution. Okay. Once all the parallel DNS resolution is done, then only it is going to show you all the port details. Okay. As of now, 1 minute 51 seconds have been completed. Last time the entire scan is completed by 140 seconds. 140 seconds means 120 means 2 minutes and 40 means 2 minutes 40 seconds. Okay. Yeah, now you can see it took 153 seconds, which is more than our without DNS resolution scans actually. And this time it tried to extract DNS resolution for any IP address that is possible. And I also observe more IPs have DNS resolution. Only one did not have it, but every other IP address has DNS resolution. Okay. So like that, the minus n minus r will deal with DNS. Like I was saying, I can use a custom DNS with the help of hyphen hyphen DNS hyphen server or servers, and you can provide more than one server also. For now, I'll just go with Cloudflare DNS server, that is 1.1.1.1. Now, whatever DNS resolution that I'm doing, all that will happen through Cloudflare as that I provided there. Apart from that, if you have more than one, you can provide all of them separated by commas, and you will be able to get response for all of them. Okay. Similarly, you can perform trace route using hyphen hyphen trace route. Trace route is where between you and the target, whatever devices are there, like networking devices, firewall devices, all of them you will try to identify. By default, your system will have 30 maximum trace route allowed. So if I say hyphen hyphen trace route, that will also do trace route once the regular scan is done and will give you how long it will take or how many hops it will take to reach your target. So see, now it will take approximately 16 hops to reach the targets. First your router, then go to Hyderabad static VSNL hop, then you go to Mumbai, then you go to Marseille, I think that's also a location. Then it goes to Paris, then it goes to Zio, I guess. Okay. Then in Zio, it went to another thing like IPYX 136.392 model. And then there I see Dell Rapid DNS host is reached. Okay. So which means how many devices are part of your network in the middle, all of that you can see. And some of them are non-descriptive. You don't know what they are because again, due to security reasons and everything. Okay. My command prompt is damaged. Now let me open one more. Great. My machine itself is damaged. Yeah. So far we took a look into host discovery and also we took a look into typical target specifications. Next we'll see what more are there. My target is restarting. Okay, let's log in. Okay, that's good. So let's see. What else do we have? So far we talked about up to this. Next, let's take a look into scan techniques. Scan techniques, as the name says, we can decide what type of scan we want to do. Okay. First, we have our, a Synstill scan, TCP Connect scan, ACK scan, Windows scan, and Maimon scan. Then we have UDP protocol scan. All of these are TCP scans. So in case it is not already clear, all of those are TCP scans. Then we have UDP scan. If you want to perform UDP specific scan, you can do that too there. And we have ACK scan specifically for what should I say? firewall detection you can do with the help of ACK scan, and then you have window scan. Actually, window scan is quite different actually. So generally, when you're doing any kind of TCP communication, how much data the target can accept. Okay, for example, let's say you have 1 GB of data. So can the target accept all the 1 GB data at once? No, right? So to decide how your target can actually receive the traffic, you'll have the windows. Okay, so it is pretty much like AXCAN, but like I said, it depends on how much data it can accept and all. So it will have a window size. Window size means the size of data it can accept. So depends on how much data it already accepted. The window can be big or small. Okay, so you can try sending various different types of packets. Okay, and then if the systems actually allow that, that confirms that if the specific kind of technology is there on the target or not. Otherwise, you will know that the outcome of it. Okay, so for example, if the target, let's say, what should I say? The target is available out there, and if I send a Windows specific scan, most of them don't support whatever you mentioned. They decide how much data you accept or how much data you don't accept. So when you ask for a custom window size, it may completely reject your traffic. Okay, so telling you that if the host is available or a specific kind of defense mechanism available or okay. However, if it is not responding anything and then just receiving or just getting data dumped, probably something is wrong with the target. So you'll have to keep that in mind. Okay. So especially you can use it to identify if a port is really open or is it filtered or is it closed. Such kind of things we can know, because if it's open, then only it mostly cares if the packet is sent within the specific window or not. Okay. So similarly, we have ME scan. ME scan, it actually you can use. What should I say? It's pretty much like your XMA scan. So far, we did not talk about XMA scan, but again, ME scan is where you send odd kinds of packets to the targets, and some targets will accept them, and some targets will not. So let's say Windows will not accept the packet and Linux will accept the packet. So by sending packets to the target, if it accepts, you will know that since only Linux accepts it, your target might be Linux. And if it is not accepting it, since we know Windows doesn't accept it, we will assume that the target is Windows. So like that, my mod scan will work. Since special scans like XMAS, Spinal are more popular, most likely you will not see MIMON scan being performed in the classes. Same with Windows scans also, like the AX scan will do the same job. So that's why you don't see Windows scan being performed again, since there is no noticeable difference. Okay, so let's do this quickly on the targets and let's see what we'll get. Nmap minus smallest capital S 160. First, I'm doing a synstill scan where only half TCP three-way handshake will happen, where instead of sending SYN and receiving SYNAC and sending ACK, it will only send SYN, receive SYNAC, and that's it. It will not send the final acknowledgement packet. Because of that, your results will be faster, and because you're not sending final packet, less number of traffic will be there, less number of logs will be there. Okay. So that is why it is called as SYN stealth scan. You are sending SYN packets, and also you are doing it in a stealthy approach. Okay. So yeah. Next, let's do TCP connect scan. This is where you'll do full three-way handshake. You send SYN packet, you receive SYNAC packet, and you will send acknowledgement packet also. So this is useful when you are performing scanning on OT devices or any other pivoted networks or unstable devices. This is suggested. Otherwise, it is not recommended because it will generate more logs and more traffic. Okay. Then you have ACK-scan. ACK-scan can be used to identify if the target has a firewall or not. Okay, see, now it says the target has 1,000 unfiltered ports by identifying if the target has firewall or not. And like I said, Windows scan will do pretty much same. See, it says even though the target has all the port numbers open, it says all the closed ports are there because the window that you set is not accepted by the target. Okay, so next let's do Mimon scan SM. Again, same response. Even special scans also will give the similar kind of response, but in a reverse way. So, for example, if you do it on Windows, they will show you different type of response. Okay. So, yeah. So let's see. So far, we have done all these. Then we have UDP scan. UDP being unstable by default, UDP is not selected. But if you want to identify what UDP ports are available on the target, you can perform it. But be ready to wait. Sometimes it could be super quick or sometimes it could be super late. So keep that in mind. So now I launch UDP scan, and if I scroll up, every time you get TCP ports, but with minus smallest capital U, you get all the UDP ports. Let's see what UDP ports will get on the target. Just 4% done. Let's do one thing. Let's name it and then we will proceed to the next scan. So yeah, as we have discussed, EXMA scan, fin scan, null scan, our special scan trinity. So as usual, if you give your targets, if they are Linux, the response will be like this. Sorry, not 160, 160. Response will be like this. You will get the port numbers are open if they are open. But if it is a Windows target, let's see. I did not have Windows target. Let me start a Windows target. And if I do the same thing on Windows target, it will say ports are closed even though they are open because they do not accept our special scan flag set. Okay, open the command prompt, check the IP address of Windows. One moment. It's in the MAC network. Let me change it to bridge adapter. Now we check IP address again. Okay, 141 the IP address is, so 141. Even though it has port numbers open, when you do EXMA scan, it says port numbers are closed. But when you do a regular scan, you can see ports are open. See? So this way, by performing these special scans like EXMA scan, fin scan, null scan, you can know if the target has, Windows kind of operating system or Linux kind of operating system. Okay. So yeah, let's do the remaining two also. FinScan, NullScan, same output, just like earlier. If you do it on Windows, they'll give you one response. If you do it on Linux, they will give you another type of response. Okay. Here we have done FinScan. Here we have done NullScan. So again, in the EXMA scan, in the theoretical presence, it will send fin push urge flags, which are odd flag set combination. So similarly in the fin scan, you will send the fin packet directly, and in the null scan, you will send a packet without any flags, so confusing any kind of Windows targets, denying or rejecting your packets. Okay. Whereas if you do the same thing on Linux, which is like 160, they respond with ports open like that. Okay. Same thing you do for fin scan, you'll get the response like that. Okay. Let's check UDP scan how much done. 22% done. Okay. So then you have scan flags. If you want to customize the flags, scan flags according to your requirement, You can do that here. Let's say hyphen hyphen scan flags, flag or flags, scan flags. And then you have to provide flags here. So you can give, like, if you want to give urgent flag, give urgent flag. Okay, if you want to give fin flag, give fin flag. Let's say I want to perform a scan with push flag. Okay, hyphen hyphen scan flags, and then uh, target 160. Let's see how the target will respond. Linux target will respond when you send push flag basic scan. Okay, hit enter. See, it says all of them are filtered. Now, what happens if I do the same thing for what? 141. That's a Windows target, and as you can see, it says ports are closed even though they are open. Whereas in the Linux, you can see it says closed ports, and these are all filtered, which means filtered with this flag. But if you do a regular TCP scan, let's say do the same with SYN scan or SYN flag, you might get a different response. See, now they are all open. So what flag it sends, for example, in the TCP scan or an ACK scan or in the XMA scan, they have some port flag sets already. If you want to customize them, experiment with them, different flags and all, you can do that with the help of hyphen hyphen scan flags. Okay, you can give multiple also. I can give SYN and push also here. So like that also I can send information. So like that you can use multiple flags or whatever flags you want to send. So that is hyphen hyphen scan flags. Then we have minus smallest capital I, a zombie scan, also known as idle scan. The concept of this one is very simple. Sometimes in a network, your IP address may be blocked to send traffic to the target, but other machine, other IP address may be allowed. Okay. So in that cases, what you can do is identify that available allowed device IP address, and then you can give that IP address in your scan. So when it is scanning, it will try to use your IP address to talk to the target. Okay. So we can use that with minus smallest capital I like this. Let's say assuming that uh, my IP address, which is what 159, is not allowed to communicate, but 10.0.0.100 is allowed to communicate. In that case, I'll give my smallest capital I and 10.0.0.100. So Nmap will try to send packets, through that particular machine or with that specific machine IP address. So target will, might get confused and give you response. Okay. So yeah, let's execute. Okay, as you can see that it says idle zombie scan cannot be performed because host did not return. So for this to happen, the target should have this specific port number open. Also, the machine should be also running. Let me do a regular scan. Let me do a regular scan. Okay, we have all these ports. Now, which device should I take? Let me find out open ports. Okay, now let's try this 189 port number 80. Not all ports are supported, but let me try with minus 80 here. So if I give 80 with 189, Okay, using zombie. It's trying something. Let's see what it will do. Also, we get a warning saying that many people use -pn to prevent pings from their true IP. So also, if you ask for more time, you may get like more reliable scan results. But I'm comfortable with what I'm doing, so let's just wait. I should have removed the scan flags. They're odd. Since we're already doing advanced scan, it doesn't matter. So let me scan now. Okay. So yeah, while this is going on, let's talk about other one. Like here we have minus SY and SZ, specifically SCTP protocol actually. So if you have any target with that specific kind of SCTP, SY, SZ kind of protocols, in that situations you can use this. Okay. So it is again advanced scan. So we don't have SCTP to experiment with that, but if you have, you can, perform scanning on the target using SCTP protocol. So there is that. Similarly, you can go with IP protocol scan also. Most likely not required all the time, but if you want to, the option is available. So let's see, where is it? My zombie scan is still going on, so let it continue. Wow, taking a whole bunch of time. So yeah, similarly we have minus B if you are performing any kind of you know FTP bounce based scan. If you want, you can do that here with bounce. Okay, so in other words, FTP protocol allows what should I say? Um, Proxies. Okay, in other words, in simple words, proxies also known as relays. So which means your traffic will not go directly to the target, it will bounce off of, or it will relay through, or it will proxy through some other target. So that target you can provide here. So if you have two targets with FTP, and if one of them supports FTP bounce mechanism, then you can use it to send traffic through that particular device. Again, another bypass or what should I say, evasion kind of technique actually. So there is that. What happened to my UDP scan meanwhile? That is also still going on, 70% done. Meanwhile, my zombie scan completed and it said, sorry, unable to obtain meaningful results for the proxy. So it doesn't say anything wrong from my side. It simply says the proxy did not respond properly. So So yeah, anyway, this is how you can provide the idle zombie device. So essentially, it will try to use that another turned on open port machine to send traffic to the target. Okay. So again, we could not get anything meaningful out of it, at least now. So, but the option is very cool and advanced. So it's better to try it out when you have any kind of complex networks. Okay. What about UDP scan? 74% done, probably 2 more minutes it will take. Meanwhile, we have port specifications, and you may have used it multiple times. You can give -p, okay, and after -p, you can give single port, or you can give two ports, three ports using separated by commas, or you can give port ranges using hyphen, okay. So also you can give -p minus to scan for all. That is same. So if I say nmap 10.0.0.160, you can use single port, you can give two three ports like that, or you can give a range of ports like that, or you can also give all ports using minus P minus. And when I'm scanning with minus P minus, if I don't want to touch any single port or something, I can give that using exclude, just like I could give with IP ranges. I can give port ranges also to exclude and not scan that specific range. For example, see, I scanned all this, right? Let's say I don't want to scan anything above or anything between 6,000 to 40,000. So I can say hyphen hyphen exclude and what? Exclude hyphen ports, then I give 6,000 to 40,000. Okay, now same scan will be done, but anything between 6,000 to 40,000 will not be scanned. As you can see, 6,000 to 40,000 no longer exists. Okay, then we have minus F. Fast scan will only scan for 100 port numbers. So typically you will scan for 1,000 port numbers when you don't give any IP address or any port range. 1,000 ports will be scanned, but by giving minus capital F, you'll only scan 100 port numbers, thus giving you results faster. So that is how it is called as fast scan. Okay. Then you have minus R. So generally, when you give port numbers minus P something, it will scan randomly, but giving minus R will scan randomly. So if I give minus P minus R, that is going to scan ports randomly. Okay, but again, result will be same, but it will scan it randomly, saving you maybe some time. Okay. Then you have hyphen hyphen top ports. Let's say you don't want the top 100 ports, but also you don't want the top 1,000 ports. Let's say you want top 700 ports. Then what you can do, you can give NMAP hyphen hyphen top hyphen ports and give 700. That is going to scan only top 700 ports, not 1,000 ports. Okay. So like that, you can decide how many ports you want to scan in the top list. Similarly, we have ratio. Again, if again I'm not very much good with math, but you can give ratio of how much top ports and how much unpopular ports you want to scan. If you want to give that, you can give that. Okay. So let's see, UDP scan done. Is it done? Not done. Okay. 95% done. Let's get this over with. Okay, finally UDP scan is done. And here I can see that UDP scan, UDP port results 53, 68, 111, 137. All of them are UDP ports now. And most of the times people will forget that UDP ports exist. And sometimes UDP ports also can give a lot of details which you may miss and not focus on if you don't observe them. So don't do that. Go with them. UDP ports also if you have time. It will take time, so keep that in mind and then you can proceed to use them. Okay, so with that, port specification scan order is also done. Next we have service or version detection scan, and also we have script scan. Let's talk about both of them because pretty much they are the two options. Okay, service and version detection scan you can do with giving minus smallest capital V. Like here we only have port state service, but by giving minus smallest capital V, you will be adding one more extra column called as version. And then there, the NMAP will probe the target machines and then talk to them to extract the backend software versions. And like this. Okay, see extra column added with all the extra details. Okay, these details will play a very vital role in vulnerability scanning or vulnerability extraction actually. So very important. Similarly, we have script scan, which is minus capital C after small s. Okay, so this is going to use internal NMAP Lua scripts in order to extract the backend services. Okay, and then they will try to extract even more details from each and every service. So when I give minus smallest capital T without any additional options, you will be doing it on basic, default safe scripts. Okay, so if I hit enter, that is going to take all the default safe scripts and then use those safe scripts in order to extract the details. Okay, let's see what we'll get. Since each port can have multiple different type of script options, this will take more time than what we could generally take. So obviously it will take more time. Wow, how long it's gonna take? Yeah, almost there. 96% done. Let's see. Okay, it's done. Now, if you scroll up, you can see for every port number, whatever safe scripts are there. For example, see for port number 21, we have FTP anon script, FTP system script, and yeah, I guess only two of them are there. Then for SH, we have SH host key script. Then for 25, we have SMTP commands, SSL cert command, and SLV2 command. Like that, bunch of different types of things are there. And all of them will be tested against the target, and whatever information that you receive, that will be shown to you in your output. Okay. So again, more about this we'll talk in a moment. Now let's see what more options we have under version detection scheme. So by default, you'll go with the basic thing actually like a default option. But if you want to go with more intensity level, we have levels from 0, the lightest, and 9, the strongest. And if you want to specify how deeply or how intensely you want to extract the details, you can mention that here. Okay. So for example, let's go to our here hyphen hyphen version hyphen intensity. Let's say I want to go with 7 intensity level. Okay, so if I hit enter, okay, smallest capital V as well. Now same version detection scan, but the amount of information we try to extract or the amount of depth it goes into will be more. Okay, so probing with more protocols and trying with more values, all of that it will try to do the more intensity you give. Let's say, what if I give 9 intensity, the maximum? Okay, trying all the protocols, all the mechanisms. Okay, see, this is the max intense level of scanning of version identification that we can get through, and this is what we got. What if I go with the lightest? Let's say number 2, not lightest, but lighter. Number 2. Okay, see here, when I went with number 2 intensity level, you can see that 2049, no information, 513, 514, no information, and 111, no information. Total 4 port numbers did not give any response. But when I went with 9 intensity, you can see that only 2 port numbers did not give the response. The 2049 gave you response and also 111 gave you response, which did not give response when you went with lighter scan. So like that, The more options you go with in the more intensity option like 9 will give you more version details, whereas the lighter ones will not. Same thing you can go with commands like this. Version hyphen light means automatically it is going with intensity 2, whereas version hyphen all means it will go with intensity 9. Okay. Apart from that, if you give hyphen hyphen version trace, everything that it does, every error, every other thing it will get, it will show you all of that. Let me show you here. See, everything it does, every success it gets, every failure it gets, all of that will be shown to you. So if there is any problem with unmap or the target, it will be easy for for the devs to debug. Okay. So those are the options we have in the version detection scan. So most of the time we use minus smallest capital V, but you can also change how deeply you scan, get more details, all of that you can do with additional options. Okay. Now let's take a look into SC also. Earlier I told you SC means equivalent to hyphen hyphen script equal to default. Okay. So other than default, we also have a lot of other options also under this. Okay. So for example, we have scripts like authentication based scripts, broadcast based script, brute based scripts. Okay. Similarly, we have discovery based script, DOS based scripts, exploit based scripts like that. We have a lot of different types of script categories, and by default, when you don't give anything, you will go with default. Okay. Default means all kind of scripts will actually come under what should I say, with best speed, best usefulness, best reliability, best privacy, like that. Whatever scripts will provide all the best features for the scripts, all of them will be used. If you don't want that, you can go ahead and use a different one as well. Okay. For example, like this, you can give hyphen hyphen script equal to, and then give any kind of individual script or folder, list of file folders, or you can give categories also. Okay, let me show you. So here we did earlier default one, right? So let me do another one. 10.160. Then if I say hyphen hyphen script equal to, let's try discovery scripts. Let's try all the discovery scripts. Okay. NMAP might have a lot of discovery scripts actually. Now, by providing this, it is going to use all those discovery scripts and will try to run them. Some of them may take shorter time, some of them may take longer time. Let's see what we'll get. Okay. Already I see a lot of information on screen. Pre-scan results. These are all pre-scan results. It says multi-cast values, MLDs, IPv6 details. So like that, you can give categories. Like I said, we have vulnerability categories, version categories, safe category, malware, intrusive, fuzzer, external, exploit, DOS. All of them are available. Like I said, you can find more under nmap.org website. So explore it when you have some free time. Wow, still scanning. I should have went with maybe any other. Oh, at least 99% done. That is good. It's been 2.5 minutes. Let's see what it identified. Apart from that, while it is doing, we can find more of Nmap NSA scripts under. Yeah, I think yeah, this is good. They are available under /vsr share nmap scripts directory. So go to that directory and you will see all the scripts that are available here. And see, some of them are enumeration scripts, some of them are information scripts, some of them are exploit scripts, some of them are version scripts. So same thing, some scripts will have some kind of task or goal, and they will try to achieve that goal with the help of these categories. Okay, you can also give individual scripts also. Once this is done, I'll show you that. Okay, so yeah, see here you can give script hyphen args. Again, some scripts will actually take additional parameters as a customizable values. For example, let me see. Here we have like HTTP brute, right? By default, HTTP brute will use internal default dictionaries. However, we can change what other dictionary to be used, or how long it should wait for the scans, or how long it should wait for timeouts or host responses. All of that we can control with the help of these additional parameters. And we can configure those parameters with the help of this hyphen hyphen script hyphen args. Okay. Same way, if you put all the arguments into a file, you can use that as args file. Both of them will do work in the same way as list of files or list of IPs or IPs in a file. Okay, same logic here also. So provide all the necessary script arguments in a file, and it will also do the same thing. Or you can write them on the fly using hyphen hyphen script hyphen args equal to, and provide the parameter, the value, the parameter, and the value. Same. Okay. So is it done? Still going on. Okay, I'll let it run. Meanwhile, let's start working on this. Okay. So like I said, I'm looking for, let's say SH. Okay. So here we have SH hyphen brute, right? So let me see. Do we have the option here? See, there is an option called as hyphen hyphen script hyphen help, and then you can provide any kind of script, and that option will tell you what more you can do with it. Okay. And map hyphen hyphen script hyphen help, and then provide the script name. That's going to tell you what it will do. As you can see, it comes under categories brute and intrusive. Okay. And what it will do, it performs brute force password guessing against the SH servers. Okay. To know more, you can open this nmap help link. So right click, open. There you will be provided with the additional options that you can customize. Okay, see, under script arguments, you can set up timeout. Okay, you can set up credential service or credential global. Okay, or you can provide username database or password database like this. Okay, now if I take it, let's do the same here. Okay, so yeah, see, this is how I will be using the script. So first I have hyphen hyphen script equal to sh brute, the brute file that I want to use. Then the additional options that I want to give them are hyphen hyphen script hyphen args, user db, and then I provide username list. Like I have a users list like, let me check, what is the file name? User.txt. Okay, I'll give user.txt. Similarly, pass db, and then we give password list pass.txt, and similarly I can give timeout also. Timeout is given there 4 seconds, and then the target IP address will be 10.0.169. Now, sorry, 160. So instead of using its own database file that it has, now it is going to use a database that I provided and take the timeout value as I have provided. Now let's see, hit enter. Now you can see these are the credentials that I provided in the user.txt and pass.txt dictionaries. And if any one of them matches, I'll be able to get them by the end of this particular scan. Let's see if I have anything. Depends on your dictionary size. It may take more time or less time, so keep that in mind. So yeah, like that you can use script options. Either give hyphen hyphen script equal to one script name or the category like I did earlier, and then finally it is done. Next, you can give additional arguments using hyphen hyphen args, and to know what arguments it supports, you can use hyphen hyphen script help equal to. So take help of that. And if NMAP releases any new scripts, if you want to update them or update the existing one, you can use hyphen hyphen update db. You'll see that also. And by giving hyphen hyphen script hyphen trace, you can see everything that you sent and received. If you want to perform debugging, you can do that with the help of that. Okay. Now password tracking is still going on. Meanwhile, let's take a look into this discovery category scan that I did. Okay. We did the whole category scan, right? See now, every port number that it identified, for that, whatever discovery scripts are there, all of them are used, and we are provided with lots of information here. Let me scroll up and let me start from starting. So much information we have. See, it's mentioning, saying that what targets should be used there. So starting with this, once the scan is completed, scan report started from this. On 21, first we have FTP system status details. Then on SH, we identified banner, we identified host key, we identified algorithms. Then on 23, we identified banner, we identified telnet encryption. Then on 25, SLSR details extracted, banner and ciphers are extracted. Then date, open relay details, SMTP command details are extracted. For DNS, NSID is extracted. All the other kind of protocols, if they have any information, it tries to extract that too. For HTTP, it identified date, mobile version checker, chrono, feed, authentication finder, and under authentication finder, it identified several links which are actually there. If you open any of these links, you can see the login forms it identified. See, all these authentication finder things actually it identified, and I can see all of them. Okay, it checked for referrer, it did trace route, it identified for user agent, different types of user agents are allowed. See, Firefox, libw, php, snoopy, crawl, all these kind of things are supported, it says. And the comment display, all the comments which are available on the target page. Sometimes comments can have some hidden, information actually, so that extracted. So like that, for every port number, whatever discovery category scripts are there, all of them are used and all the details are extracted. Okay, so like that you can use categories to scan. And what happened to my password tracking? Still going on. So yeah, like that you can use script scan. Now I'll let this password tracking continue, and once it is done, we should be able to get the response. Okay. So while it is going on, let's talk about OS detection scan. It's again very straightforward. We give minus capital O to enable OS detection. So OS detection works by observing how the target responds to open ports and how the target will respond to closed ports. Okay, so what it will do, it will send traffic to all the ports that are available, and it will try to observe open port responses and closed ports responses. If the target doesn't have a closed port or doesn't have an open port, then OS scan cannot work. Okay, Also, to do any of this, you need to have administrator privileges. So you should always run this as a root account. Okay. So with those two limitations in mind, apart from that, you can also, increase more aggressive guessing or limit to only the promising targets. Okay. It will look something like this. Unmap minus capital O 160. If the target has open ports and closed ports, then only it will work. If it is not, let's say if the target is like uh, 159, which doesn't have any open ports, you will not get the OS scan. See, OS scan cannot work. Okay. Similarly, if the target has all open ports only, for example, minus P I gave only 21. Only open ports we are giving, not closed ports. So if I hit enter, that also cannot work perfectly. See, warning, OS scan results may be unreliable because we could not find at least one open port, one closed port. Okay. So like that, minimum one open port, minimum one closed port is must, and you should always run this with root privileges. Now, on top of that, like I said, you can increase or decrease the aggressiveness using hyphen hyphen OS scan limit or hyphen hyphen OS scan guess. Limit will go light and guess will go more aggressive. Okay. So this is more promising outcome. Whereas if you don't want promising, you can go for more aggressive using guess command, which will try to identify the OS more detailedly. But remember, anything more aggressive can give false positives. So you have to keep that also in mind. Okay. Meanwhile, my cracking is still going on. So where is that? Next, we have timing and performance section. Again, as the name says, you can decide how fast or how slow you can go. Okay. For example, here by giving minus t within 0 to 5, that is your speed range actually. Think of it as like your fan speed controls. We'll have 1, 2, 3, 4, 5 speed controls, right? Same thing here also. We have 0 to 5 time controls, 0 being the slowest and 5 being the fastest. Okay. So you can give that to increase or decrease your speed. So if I give 160 minus t0, that will be the slowest scan. But when it is slowest, you will be able to get results much more reliably compared to the fastest. Okay. So still going on, right? So on the other terminal, if I give minus t5, you will see, that is the fastest and minus 0 is the slowest. You hit enter, it will tell you it's going to take a lot of time. Come on, even enter also not giving anything quickly. Apart from this, simple, 0 to 5 speed controls, you have more type of speed controls as well. For example, minimum host group or maximum host group, which means in a scan range, how many minimum targets you are scanning and how many maximum targets you are scanning. Okay. So for example, when you scan for like huge ranges, you will be scanning 4096 IP addresses at the same time. Okay. For example, if I take a big range like 9 dot or 122.166 like this, see, when I'm doing this, you are actually scanning how many? 4096 cone scans or hosts at the same time. Because this particular range contains thousands of IPs. You can't scan all of them at the same time. So it will divide them into multiple 4096 hosts of groups and then it will scan them. Okay. So I can either increase this number or decrease this number with the help of this minimum host group and maximum host group options. Okay. So that's what I can do here. So yeah, um, let's do that. Now if I do the same thing, saying hyphen hyphen min hyphen host group, min hyphen host group, and I'll say 1024. Actually, now it is going with sorry, minimum, right? Minimum, if I say 8192, I'm assuming that is correct. 4096, 4096, 4096 into 2. Yeah, 8192. So earlier, the maximum number of scans it's going to scan are 4096, right? Now, if I say minimum host group itself is 8192, let's see how many devices it will scan at the same time. Okay. See, it says you specified a highly aggressive minimum host group. So if I hit enter, see, earlier it is scanning minimum 4096, but now it's scanning 8192 at the same time. You can decide how many machines it will scan at the same time. Okay. Similarly, if you want to reduce it, you can give maximum host group and then give, let's say, 100. Then it will only scan 100 computers at the same time, or let's say 128. Now you can see, okay, is it not that? What's the command? Max host group hyphen hyphen max hyphen host. Yeah, that is correct. Mm, max host group. I gave max right number, but what is the problem? Max hyphen host group. Min is accepted immediately, but max is not. Let's try again. What if I give 8192? Will it work? Yeah, max is not accepting for some reason. Maybe probably a bug in the NMAP or something. But anyway, if it works effectively, it should take whatever value you provide like this and affect it like this. But when I do the same thing for hyphen hyphen max host group, for some reason it is not accepting. Either I give lower or I give higher, it is going with the default option only. The syntax is also right only, max max hyphen host group. Same value, it's not even different. Okay. So anyway, like that you can give minimum maximum. Probably with the next NMAP update, it should fix it. Then we have minimum or maximum parallelism, which means generally NMAP will not scan like one device only at a time. To save time, it can scan multiple devices. So you can control how many more or less number of communications you can send at the same time. Obviously, the more you give, the faster it will be completed, and the less you give, the slower it is going to take to complete. Okay. So then we have minimum RTT, maximum RTT, and initial RTT. So generally, RTT means retransmission actually. So retransmission means in TCP, when you send any type of packets, you send 100 packets, not all the time all 100 packets will be delivered. Sometimes 70 packets will be delivered. Sometimes 75 packets will be delivered, like that. Okay. Whatever packets are dropped, the target will ask, hey, I lost these packets in the transmission. Can you send them again, calling them retransmissions? Okay. So these retransmissions you can control with the help of this, again, minimum, maximum, initial retransmissions. So by sending RTT timeout, you can decide for how long you will wait for that particular retransmission request. If it is taking more than the timeout that is given, it will, not send them or not receive them. Okay. Similarly, you can control how many maximum retries you will do. So if you are not able to connect to the target once, how many more times should you try? Okay. By default, it will be maybe 3 or 5 times. You can increase it or decrease it with the help of maximum retries. Same thing with host timeout also. Generally, timeout means you try to talk to the target and in response, you wait for the target response. How long should you wait? That is called timeout. So by again providing the time, you can provide time in this following format. You give like 30 M for 30 minutes or 20 S for 20 seconds or 50 ms for 50 milliseconds, like that. You provide a time, and up to that time it will wait or not wait after that time, depends on whatever time frame you provide. Okay. So this is helpful if you're dealing with a very slow target or very fast target like that. So if the target is very slow, it may not respond to you quickly. So by increasing the host timeout, you will get better responses. And similarly, by if the target is faster, by decreasing the timeout, you will be able to get results much faster. Okay. Similarly, we have scan delay or maximum scan delay. So especially if the target has any kind of defense mechanisms and you don't want to get caught, or maybe the target is too delicate, if you send so many packets, the target might crash. In that cases, you can use a scan delay to wait for some time before you start scanning. Okay, so for that situations you can use again you can provide time 30 minutes, 20 minutes, 20 seconds, whatever time you want to give, you can give. So it will wait between those scans so that not you will give the time for the target to collect itself back and then respond to you again. Okay. Same way we have minimum number of packets, maximum number of packets to be sent. Okay. So give like let's say minimum rate 100. Let's say if I give for a scan 10 dot 0.0.160. If I say hyphen hyphen min hyphen rate 5, then it will start sending packets to the target only 5 per second. So like that, or if I say max something, then it will not exceed whatever packets that you have sent provided here. For example, if I say max rate, so it will not send packets more than 5. Is it correct? Hyphen max rate. Hyphen max hyphen rate. Correct only. Unrecognized. This is what I was talking about. One of them is working, but I do the same thing for other. It is not working. Probably NMAP issue, as we have seen. Hyphen max hyphen rate. Sorry, it's mix I have written. My bad. Did I do the same kind of mistake last time? Anyway, so like that, you can actually decide how many packets you should send minimum, speed control, how many packets you should send. Similarly, how many packets you can send maximum to the target, controlling the number of traffic. Let's say, what if the target has a firewall rule of capturing or detecting the attacks if they exceed 30 packets per second? Then you can give maximum rate 29. So it will only send 29 packets per second, downplaying the speed, also giving you more accurate responses. Okay. So that's what minimum maximum. As you can see, this will affect both time and performance. So if you go something smaller, you will get results slower, but definitely more reliable. Whereas if you go faster, you will get results faster, but sometimes you may miss out some things. So you have to keep that in mind while you're using timing options. Okay. So then we have firewall and IDS evasion and spoofing. And then we have output, just we have 3 more sections. Okay. So firewall IDS evasions, how do we do that? Okay. The first option is hyphen small f, also known as hyphen MTU. Okay. So hyphen MTU or hyphen F is nothing but uh, fragmentation scan. Fragmentation scan means when you're sending any traffic to the target, it doesn't go in a single packet, it goes in multiple packets. And using minus F or minus MTU, you decide what will be the target packet size. Okay. So if you give minus F, it will be the default, it will take automatically and it will calculate automatically. Okay. Or you can decide how much packet size will be using hyphen MTU option. Okay. So if I use NMAP, let me show you how it will look like in Wireshark. Regularly, if I type nmap 10.0.160 regular scan, see this is how the traffic will look like. You send SYN packet, you receive reset packet. Or if the port is open, probably on the top we'll have that SYNAC responses. Yeah, see. If the target is open or if the target port is open, you will get SYNAC response. Still I did not have it. I need to scroll up even more. Let me use a scroll bar. Okay, so see, you send SYN packet and you receive SYNACT packet like this. Or if the port is closed, you will get reset packet like this. Okay, so here this is how a regular scan will look like. Let me make it even more clearer by scanning only one port, minus P80. Okay, you do that. What do you get? You get, you send SYN packet, you receive SYNACT packet, and then you close the connection because you are doing a SYN still scan, not TCP connect scan. However, same scan if you do with fragmentation scan, see how it will look like in Wireshark. See, one packet, it's not sent as a one packet, it was sent as two packets fragmented like this. Okay, so that is what you will do in fragmentation scan. You cut the packet into multiple pieces. By default it went with three pieces, sorry, two pieces here. Okay, if there is any signature within that particular packet, it will be broken down and you will no longer be able to use it to to detect or to get detected. Okay, whereas if you have any kind of specific value in mind, you can give that also. Okay, so let me do that. We can give minus minus mtu and give a value. Let's say, what if I give let's see, mm, we need to give a number. Let me give 8. Okay, so now let me restart. Okay, now you can see again fragmented into two packets, right? What if I increase that to 16? Any difference? Okay, now you can see that the packet is only sent in one specific thing, not two. What if I go with 24? Scroll down. Did I miss anything? Let's see. Okay, now you can see the fragmentation did not even happen. What if I go back to 16 again? See, when I do 16, one fragmented packet was able to identify. And when I do 8, two fragmented packets are identified. But when I do 24, we can see that the packet is so fragmented, Wireshark was not even able to identify that there is a packet that got fragmented. You see, even Wireshark was not able to identify the fragmented packet. Same way, if the packet has some kind of signature, by cutting that into multiple small pieces, if the target has any kind of signature, that will not match with the target anymore. Okay, so like that you can use minus small f, or you can use hyphen hyphen MTU, maximum transmission unit, to decide how or how many fragments you will be sending to the target. Okay, similarly we have minus capital D, that is decoy scan. Again, it will use multiple different decoy IP addresses to convince the target that that you are not you. Okay, if the target is blocking you based on your IP address, you can go ahead and act like the packets are coming from someone else. Okay, so let's see. 160 minus D 10.0.1. So if I give this, what happens is I will scan, but NMAP will send to the target scan packets with the target decoy IP address, which is 10.0.1 also. Okay. So in this case, the target will receive like more kind of IDS detections and such kind of things. So that might think them, or that might make them believe that their IDS is malfunction. Okay, so if I give like multiple IP addresses, 10.0.0.1 naught, let me do one thing. Let me set up a snot here so we can understand it easily. Okay, is my IP address correct? 159 it is. I believe the IP address may be wrong. Yeah, wrong. 159. Starting's not now, and if I go to another attacker machine, let's say this attacker machine. So generally, if I perform a scan right now from the parrot machine, it will detect that from parrot machine. Let's see. If I open tool and map minus smallest capital X 10.0.159, what happens? It will detect my IP address like that. Okay. But if I do a decoy scan, if I give 0.1, comma 10.0.189, comma 10.0. What is my IP address anyway? 236 is my IP address. 189 and also 10.0.2. Like that, I'm giving multiple decoy IP addresses. And if I hit enter, see here, now not only my IP address detected 236, but it also shows 0.1, 0.189, 0.2 also, which are innocent devices. Okay, they did not even know that I'm doing the scan, but on the target, it will look like what? They're also doing a scan, right? So what the people will think is, okay, probably this is some kind of false positive. That is why all the devices are showing a scanning. Why would all the devices scan on the same target for the same time, right? So they may write a false positive rule or something like that to whitelist us. Then we can proceed to perform scan all by our own. Okay, and they will not even think that because they think it is a false positive. Okay, so like that, by causing more confusion and false results on the target using decoy scan, we will be able to, confuse the target and then make them whitelisted. Okay, so I have seen a video on the internet actually. A person want to steal some things. So what he will do is he will steal things and then put them in other people's baskets in a shopping mall or supermarket. Okay. So then what happens? Regular people will try to leave the shopping complex, and then the detection mechanism will detect that they are leaving with something. Okay, like that, when 10 or 20 people get detected, people get doubt and call and say that there is a glitch, and then they will turn off the entire system. So the person who is actually stealing will steal whatever he wants. Same logic here also, we are generating more false results on the target. So target will think all of that is not serious, and then when they are not taking it seriously, then we will proceed to do the actual scans and get the results. Okay, so that's what decoy scan will be helpful with. Similarly, we have source IP address spoofing scan. If the target is blocking our traffic because we are not from specific IP address, we can eliminate that or we can avoid that by using a spoofed source IP scan. Okay, let's say on Parrot, I'll block my IP address. Okay, right now there is no blocking, but if I say IP tables minus A for adding minus P TCP minus S for source IP 10.0.159 minus J drop. Uh, okay, I need to give input incoming connections. Okay, now if I verify, see, anything that is coming from 159 will be blocked right now. So if I say nmap 10.0.236, let me open some ports. I opened some ports here. So it should show that SH and Apache port numbers are open, but let's see what happens. See, it says, sorry, all the 1000 ports are filtered. you can't access the target. Okay, that is because the target is blocking your IP address. The ports are there, only your IP address is blocked. How can I confirm? Say I have one more attacker. In this attacker, if I do 0.236, let's see. See here, the target actually has port numbers, but only they are not allowed from your IP address. Okay. In that case, what I can do is, since my IP address is blocked, I can use any other IP address which is not blocked to perform the scanning. For example, same target, if I give capital S and give 10.0.160, which is allowed. Now, if I do the scanning, okay, we also have to give interface name minus eth0. What happened? Okay, we also have to use minus e. Yeah, I've given. Okay, minus pn also should be given, minus pn. Now, no targets were specified. Let me give it this way. Let me give the IP address in the last. Probably it's waiting for the target in the ending. Let's give it in the ending. Interesting. It is not accepting. Okay. Okay. Oh, okay. So I think why I understand why they are not coming, because the target is there, but when you're giving the target IP address like source IP address as 160, the responses will also go to 160 from the target perspective, right? So that is why you're not getting any responses. So it's a very potentially very good thing, but since the target doesn't forward the packets back to you, you will not be able to get the response here. But a very interesting option, definitely, to pick the IP address that they'll see. At least, just like earlier, you can cause a lot of decoys. Okay, if the target has any kind of IDs or something like that, they will receive scan packets addressed with another target, and they may try to investigate them. And like that, if you do it like 3 4 times, what happens? They will again think that some kind of false positives are going generated. They may fix them or try to fix them, and in the process they may make it more accessible or more open, just like in the decoy scan that we have done before. Okay, so yeah, that is source port scan. What else do we have? We also have specific interface. We have used that also earlier, minus E interface. So especially when you have like, what if you're connected to LAN network and also Wi-Fi network? In that case, if you want to use a specific interface to perform scanning, you can use minus E. Especially when you're connected to VPNs, this one can come in very handy to eliminate any kind of confusions and go with specific interface all the time. Okay, that is minus E for interface. And again, minus G, also known as source port scan. I think this I can show you. Let me go to the target. This time, the scenario is like this. Let's say in my network, I want IP tables minus F. I want all port numbers to be blocked apart from the, what should I say, apart from the 80 port number for web communications, or let's say 53 port number for DNS resolutions, because these two are basic. Okay, apart from that, I don't want to allow any kind of communications. Okay, so IP tables minus A input minus minus S port is, let's say, DNS 53, and then hyphen J allow. Okay, hyphen S port. Unknown option. Why is it unknown option? The target is coming from, so it's a spot only. Input source port number What is the option? Let me check. IP tables minus H jump. Yeah, minus S address. I know that. Here's the port number. Delete chain new flush list replace insert. Set counters. Address S is there, D is there. Where is hyphen hyphen? Let me check. Hyphen hyphen help. Oh, okay. Sudo. Okay. Let me check. Why waste time? Export is good. I don't know why it is not working. Let's come back here. IP tables minus A hyphen hyphen protocol. I forgot to give protocol. That is why it is not working, I guess. So minus P TCP export equal to 53 allowed. Okay, allow doesn't exist. Hmm, how do we say allow?
Accept, I think.
Yes,
Accept, I think.
yes, correct. That is correct. So here, as you can see, IP tables minus L. See now, anything as long as it is coming from 53 port number allowed, then I would like to block everything else. IP tables minus A input, minus P, TCP, minus J, drop. Okay. Now I can see anything that comes with domain is allowed, but anything that doesn't come with the domain, all of them are blocked. Okay. So now if I come back to my NMAP, meanwhile, who said earlier accept? Who confirmed it?
Patrick.
Okay, Patrick. Thank you, Patrick, for
Okay, sir.
confirmation. Okay. So here I want to generally perform scan, and as we expected, now I'm sending random IP address communication, so it doesn't accept them. We will confirm that in a moment. 50% done. See, it says ports are filtered. That is because when you normally perform scan, if I open Wireshark and if I do normally perform scan, that scan happens from random 57,252, 250, 251 kind of random port numbers. Okay. However, if I do the scan using minus port number 53, source port number 53, now all the traffic will go from port number 53 only. Okay. Now hit enter, and here if I observe, see, all the traffic is going through 53 only because we are sending through 53, which is allowed on the target firewall. You can see ports are identified, which you are not able to identify before. Okay. So this actually happens in the targets actually because in companies they don't want you to open some random web pages or something else like that. So they only open certain port numbers like 443 for secure web applications or 53 for DNS, and anything that is not coming through these protocols, all of them can be not allowed. So common port numbers that we test are 53, 80, 443, and internal port numbers like 139, 135, such kind of things we can randomly try, and one of them has a chance of working, and we might be able to bypass the target firewall limitations using the scan, that is source port scan. Okay, this is one of the option that you may have used in cpent also. If you have done cpent codes, you might have seen it there. Okay, now apart from that, you can provide proxies, especially let's say if your target is not accepting them, you can use that. Or What if you are performing pivoting? Okay, when you're performing pivoting, if the network is somewhere else, your regular network might not be able to reach it, but you can set up a SOX proxy in your Metasploit framework, and you can use that proxy to send the traffic to the target. So like that. In fact, previously one of our student also had the same issue when he is practicing, and I suggested him to try different mechanisms, and one of them worked. Same thing here also. Similarly, you can add some additional random data or whatever data you like in the ending of a packet, or add some, random data without any specific thing in your mind, or any custom value if you want to add, you can add. Okay, so such kind of extra things you can do using hyphen data. Again, we should be able to see that in the Wireshark. Let's try. So if I say data string, let's try data string and map. I'm going to add chimney and to the target 160. Now if I come back here, scroll down, see telnet data, it send the content chimney here. If I expand, I can see data chimney is sent. Malfound packet, again if I expand the malfound packet, we might be able to see some data. Okay, so like that you can add, see again on another FT port number, chimney data is sent, file transfer. So like that, if you want to decide what data you want to send, you can use hyphen data string, or if you want to just, custom payload using hex string, you can add hex string also, or just add some number there. So if I just go back and give a number, data, data length, and then give number like 20, random extra 20 characters will be added to your communication, and you should be able to see that while you are sending traffic. I should have reset it. uh, okay, not this, let me reset it. Now we should see that again. Since it is random, we will have, yeah, see, random data, hex value of data we have sent, and it will look something like that. Okay, so you can use this to confuse the target signatures, by sending some random characters or some trusted characters by the target. You can confuse the target or make it trust you. So such kind of things you can do with the help of this hyphen data option. Meanwhile, my password tracking with the custom script arguments is done. You can see the outcome is available here. And my slow scan is still going on. 100% done, but still I think it is doing some closure things. Sorry, only ARP ping is done 100%. Still, regular scan is not even started. So that much slow you can do with the help of -T0. I'll still let it run. Let's see what else we can get. So yeah, like that we have firewall options up to data length. Similarly, we have IP options also. If you want to control what kind of IP parameter values you want to send, you can do that also with the help of IP options. Okay, so let's see what IP options are available. You can see them under this link, under again NMAP help options. Anytime you have any issues, you can go to NMAP help options, and this is where you can see uh, this is a, probably creator of that. IP option support and map can be found here. Also basic usage, you can, record the routing, you can add the internet timestamps, you can provide, source routing, or you can use strict routing. Like that, additional IP based communications you can do with the help of, minus what minus IP options value. Okay. So similarly, we can provide TTL. TTL and trace route are very similar. For example, by default, every computer will have 30 hops of TTL actually. So if I go for trace route yahoo.com, so like that, all these are hops. Okay, like that, maximum any device will have 30 hops configured. But if you want to go beyond the 30 or maybe if you want to go less than 30 or something like that, you can mention with the help of TTL actually. So it will hop up to that and then after that the time to live will be expired and it will no longer send the traffic beyond that. Okay. Just like we have done earlier, IP address spoofing, you can also spoof MAC address. Most of the time, MAC addresses will not be used in a typical, port scan, but in the ARP ping scan, your MAC address can be used actually. At that time, if you want to spoof it and not leak your details, you can proceed to use hyphen hyphen spoof MAC. Okay. Similarly, we have sending some kind of bad checksums. Checksums will be used to verify the packet integrity in the ICMP packets, actually, not ICMP, TCP packets. But if you want to send purposefully wrong checksums to debug the target to verify if they, you know, uh, you know, care about the checksums or not, you can use hyphen hyphen bad checksum. If the target is allowing traffic without the valid checksum, that means you can send spoofed packets, you can send malicious packets, all of them can be accepted by the target. But again, not all targets will accept it. You can verify that using hyphen hyphen bad sum. Okay, let's try. Let's see what the target will tell. Hyphen hyphen bad sum 169. See, by sending bad sum, the target is not by default accepting my, sorry, 160 it is. First, let me send that. Hmm, is it accepting bad sum? So generally 160 will not take this longer to scan, but probably because of my bad sum, it is taking more time. Let's see what we'll get out of it. Okay, interesting. Even though the target has all port numbers open or bunch of port numbers open, as soon as I send bad checksum, they are not accepting. So that means the target has a proper checksum verification before accepting the packets. Okay. So like you can see, you can try this, and if any target is responding you properly, showing open ports properly, even when you send bad sum, that means the target can accept any kind of tampered data without proper verification mechanism. So that's one good option to verify. With that, our firewall and IDS evasion and spoofing techniques are also done. And then we have output options. So in this output option, some of them we already have seen. For example, hyphen hyphen open we already have seen. Um, let's see, minus V also we could have used before. Minus V will give you details of what is happening. So by giving minus V, before V, you can see just nmap scan report, host up, not showing port details, right? But if I give minus V, that will tell you at every step of the way what it is doing. Like first it is doing ARP ping scan, then completed ARP ping scan, then started DNS resolution, then completed DNS resolution, started Synstel scan, what ports are identified, all the details will be given to you by adding minus V. That minus V we have here. Okay. Then we have minus D, generally only for debugging purposes. If you're an NMAP developer or someone who wants to investigate the issues of NMAP, then minus D is required. So let's see minus D. Now you can see we got more details, extra details like stamps, values like what protocols are used, how many bytes are sent, what DNS values used, all the details, more details that are not generally given to our regular users will be given to you by giving minus D. Okay. Then to save the nmap output, we have these formats actually. So here we have ON. ON means just whatever nmap gives by default, whereas OX is for XML scan. Specifically, some tools can actually accept nmap XML scan and they can pass information from it, like Metasploit Framework Console, or there's also one more tool called as, um, I don't remember the name now. Let me check. What is the name of it? Hmm, report generation tools. for pen testing. There is one tool available called as, I don't remember the exact name, yeah, Dradis. The name is Dradis. Again, there can be multiple other tools like that. Dradis is one of them, which will take your NMAP XML output and can pass the port numbers, IP addresses, any details that NMAP provides automatically. So such kind of situations, you can use minus O capital X to generate the XML file. Okay. Then we have minus small o capital S for script kiddie. I don't know why anyone would want to use it. It will convert that particular data into lead format, which makes it very difficult to read and all. But again, if you're having some fun, you can go ahead and do that. And minus OG is a greppable format. Greppable format means if you want to write your own script or if you want to use your NMAP output for some other purposes automatically, you can use minus OG. Okay, so let's try all of them here. Nmap minus just target 160. If I say minus on in file name like normal.txt, that's going to be same. So if I say cat normal.txt, see, same output. You perform the nmap scan, you get the same output. You read the file, you get the same output. Normal. Then let me do the same nmap scan, but this time let me save it into xmas, not xmas, XML output. Let's call it as XML output.xml. Now, if I read cat XML output, see, this will not be easy to read for you, but it will be super easy to read for any tools. Okay, so let me show you. If I load my MSF console, let's see how I can import all the data. Let me do even more aggressive scan here. Minus capital A. So more details I'm trying to extract. And in your Metasploit framework console, right now, if I say hosts, see, we have some host here. 160 is not the part of it. Okay, similarly, if I type, what else do we have? You can also type nodes, services, vulnerabilities, all of that. So if I say services, you can see we only have some ports, right? Now what I'll do is I am going to import the XML file here. Okay, how do I do that? Let's see what's the command to import. db underscore import. Okay, so type db underscore import. Then we give the file name. File name is what? Is it done? Scan is done, and the file name is xml output.xml. So if I say xml output.xml, see, importing nmap XML data, it automatically identified that that file is XML file, that imported host file and successfully done. Now if I type hosts, you can see 160 is added with MAC address, OS, version, purpose, then type services. See, all the services of 160 are automatically added. Similarly, if I have done any vulnerability scanning, if I say vulns, we will be able to see vulnerabilities of the target also. See, VSFTP 2.39 like that, all vulnerabilities can be extracted and found in the tool very easily. You don't have to add them by yourself. Same thing you can use in the Dragis framework to make reporting easy for you. And a lot of other tools will accept that XML output and you can use it that easy. Okay. Now that is XML. What else do we have? We also have greppable format. So if I say minus G and say output dot grep, so the output will be structured in a way that you can use grep command to isolate what you want to extract. Okay, let it complete. This is very much helpful if you want to write your own bash scripting tools or any other type of scripting tools and then use it for your own purposes. So let's see, done, right? Now, if you generally cat output.grep, see, this is how it will look like. So much confusing, right? But this is easy to separate. For example, I can say, let me use. grep, if I say ports, hmm, binary file matches, uh, something is missing. One moment. Let's say grep host. Ah, it's working. So here I get the details. Now in the host, I have the ports, right? So what if I say ports? For some reason, ports is not working. But let's see what else I could look for. 160 maybe. Let's try 10.0.160. Okay, now we are able to get grab the details. Hmm, I want the second line. Am I getting second line here? I think it is getting issue after it, crosses specific line because see, I asked for host value, which is available over here. It worked. I asked for IP address value, which is available over here. It worked. But as long as I'm asking anything related to this line, we are having error. So probably because of some kind of parsing error over here. See, we have some invalid characters. Because of that, it says binary file matches. So probably I think it is getting confused. Let me do a basic scan because of that it is getting confused, right? Let me do a basic scan, regular, just that. Now if I say cat output.grep, I don't see any kind of invalid characters now. Let's see if I could grep ports. Yeah, I think they understand the problem. See, earlier it had some kind of invalid characters like this because of that it was not able to grep it properly. But as long as you get plain characters which you can grep, you will be able to work with it fine. Now, what I can do here is I can use this grep to filter the port numbers and I can see them, separately and, extract specific kind of information that I want very easily. For example, if I can say cut minus D separated by commas, I can ask for F1 must specify, um, okay, seems like comma is not selected. What if I give slash cut minus D F1? Okay, let's try cut help. So bytes, I can extract specific kind of bytes, or I can cut it based on characters or delimiter, mm, field list minus F. I can go with that. Zero term. Yeah, syntax is looking good. I don't know why it is not responding. Where is it? Cut minus D space minus F1. Oh, space. Seriously, space is a problem. F2 IP address, F3, F4. Now let's separate by commas. Now I can see 21, 22, 23, 24. I can ask for multiple also, like I can ask for F1, comma 2, comma 3, comma 4, like that, and ask for multiple port numbers. I can even cut them even further, extract only port numbers or only TCP. You get the idea. Okay. So like that, I can use the grabbable command output to grab and extract exactly whatever I want. Okay. So like that, minus OG And if you give minus OA, that's going to generate outputs for all the top things, for example, like normal, xmask, and greppable. Since we are here anyway, let's also explore the script kiddie one, nmap minus s kiddie.txt. So if I say cat kiddie.txt, see here, service is written as $3RV1CE. As such is written as $H. You get the idea. Okay. It is again not productive, but it's fun. If you want to explore fun, you can go ahead and explore fun. That is this command. Okay. Like I said, you can also give minus capital OA for all popular port formats. So should I give any file name here? Let's see. Yeah, base name you have to give, not the entire file name, just the base name, like all formats. Okay, give that. Automatically you will see all formats: GNMAP, greppable format, regular nmap format, XML format. All the three formats are created at the same time if you don't want to choose. So then we have reason, one of the very interesting thing actually. So when I said nmap and target IP address, generally you'll get port open or close or something like that. But by adding hyphen hyphen reason, it will also tell you why nmap considered any specific port as open or closed or something. Okay. Hit reason, you can see that it will tell you why, because the target responded with SYNAC. Okay, in every port number, you identify the target port number as open because the target responded with SYNAC and TTL value 64. Okay, same thing if I do for minus smallest capital A firewall detection scan. Why does nmap thinks a port is filtered or unfiltered? That also we can see. Hit enter and you can see. Generally here it says reset, but since nothing else is there, we see nothing. Uh, what if I say all are unfiltered? So there is nothing crazy there. Mm, let me give SX. That also shows you some ports, right? See here, these ports are identified as open or filtered because the target is not responding. However, for all other 978 ports, they are identified as closed because for all of them, target actively responded with reset. Okay. Same thing if I do for a Windows device. Let's see the response with a Windows device. 141, I guess. Is it correct? I believe it is 141. Let me check. 141, right? So here you can see that all 1000 ports are closed because all of them they responded with reset. Okay, only Linux will not send a reset packet if you are sending any kind of special scan flags, while Windows will send reset packet to all ports as soon as it finds them. Like that, why something is decided as something you will see as a reason by adding hyphen hyphen reason. Okay, it's not something that you're adding there, you're just using or knowing what's already available there. So it only affects the output, not the scan method or something like that. Okay, similarly you can add hyphen hyphen packet trace to see what packets are sent and received. So if I take that, see, if I scroll up, every packet that you sent, every packet that you received, everything is printed here. Again, for debugging purposes, this one can be very helpful. So take a look into that. Similarly, for debugging, if the target has any kind of interfaces or routes available, it will try to print them. So let's try that. This will help us to identify if we are able to reach the target or not, or if it has any kind of other interface or not, like that. See, so it only has 10.0/24 and also these interfaces, nothing more. So that's what you can get here using if list, some other output thing. Similarly, you can append output. For example, uh, let's say you scan one target, and then when you do the same scan again with the same output file name, it will overwrite. For example, let's see. So cat kitty, right? Here you can see right now we have some data. Now if I do one more scan, let's say minus capital A scan, generally what happens is it will override the existing content, but by adding this value append output, that is going to what should I say, add to the existing one, not just overwrite it. Okay, so if you want to save more number of things, you can do that. Similarly, if you have stopped any scan, if it is saved into a file, you can resume it. I did not stop any scan so far, but let's try. I think I should provide the file name also there. But anyway, let's see append output. Let's try that. Similarly, we have non-interactive. So press Control C or Enter, something like that. Generally, they will work, but by adding non-interactive, they will not work. I think I should start using it in my classes. Let me show you how that will work. So if I say nmap minus smallest capital U 160, now as it is running, you will generally press Enter, etc., to know, right? If you add hyphen hyphen non-interactive, you hit enter, nothing will happen. Okay, so again, I'm not sure why I would want to enable that, because most likely I understand. So especially when you are writing any nmap based scripts, in that cases you don't want your current running scan to be affected by the previously executed commands or outputs actually. So in that cases, hyphen hyphen non-interactive can be very helpful. So if you want to write any scripts. So yeah, that is how it will work. Now let me see, cat kitty. Now you see, first the aggressive scan is done up to this, then second scan is done and the information is added to that. Okay, all of that we are able to do by adding hyphen hyphen append output. I could use this to contain all my nmap results in one scan only. Like first I do network scan and save that into a file. Then on one of the target I'll do port scan, save the information in the same file. So all my scan outputs can be saved in one single file only. I don't have to worry about all other type of files and forget all of that. I can use the append output to manage all the outputs in one go. Okay. So similarly, you can you can use hyphen hyphen style sheet. What it will do, it will take this XSL style sheet and transform that into HTML. Okay, so let's see. I do have one XML. Okay, but I don't have XSL style sheet. So if you have that, you can convert that into HTML output. So there is that. If you want, you can use. Okay. Similarly, you can use hyphen hyphen web XML to create a web-based output, it says. So if you want to use that, you can use. Okay. So yeah. Then we have miscellaneous options. You can enable IPv6 scanning using -6. By default, we'll go for IPv4, but you can go with IPv6 also using just adding -6. We already have used hyphen A to perform 5 different type of scans like OS detection, version detection, script scanning, and trace route. And also you'll get typical synstel scan anyway. Okay. Then you can store all of your nmap data into hyphen hyphen data directory. When I have multiple targets, I can create their separate folders and save all the output to that specific directory. So that I can do here. Okay. So you can use privileged kind of scans or unprivileged kind of scans using these options. Okay. So yeah, with that, pretty much all of our nmap options are done. Okay. Some of them we have seen practically because they make sense. Some of them we just explain theoretically because one reason I could not show any kind of practical difference between the previous scan and the current scan. And second, we don't have situation. For example, like we did not see any kind of SYSZ scans because this will work on SCTP protocol only, and we don't have any SCTP protocol device. Okay. So like that in such kind of situations, we did not go with the practical implementation, but everywhere that is possible, I have shown you how that specific scan can give you different response or more details or less details or something like that. Okay. So yeah, any questions we have up to this? If you have any questions, you can let me know, or you can, as usual, discuss in the Discord server also. Apart from that, yeah, this week we talked about NMAP. Probably we'll pick another tool and we'll, do a deep dive into that tool options and how it will be helpful for us in the future as well. So, any questions, anything that you'd like to add? I did not expect this to be this long of a session. We took like 9 to 10, 10 to 11. We started 9, right? So 9 to 10, 10 to 11, 11 to 11:30. 2.5 hours it took just to talk about NMAP. So mostly in the future we'll try to make it somewhat less, lengthy streams. And also I have recorded the entire session. Hopefully the audio also got recorded. I did not test that. I just randomly tried that. So everything is recorded. I'll try to share it in the Discord once it is ready. So yeah, if nothing else is there, I think that's all for this session. We'll again gather up with one more tool soon and we'll talk about what we have in there. Is that all? Shall we end? Do we have anything? Okay, so this is literally
2 hours later.
so okay.
And we say bye bye.